Here we go. We have a question, k size subarray maximum. So you have given an array and an integer k, and our task is to find the maximum element for each and every contiguous subarray of size k. So first we have this window. Here element is 3, so we have to pick 3 elements. In this the maximum is 3. For next 3 elements, the maximum element is 3. For next 3 elements, the maximum element is 4. So that's how we have to build our answer. And same applies for this. So let's build the approach. So I have taken the same test case. Before this, let me tell you, this question is also available on LeetCode, but instead of medium, it is marked as hard. So if you able to solve this question, you can also try the same question on the LeetCode. So let me tell you the most optimized approach for this question. So for this, we're gonna use a deck. So first we have this, and in this the k is 3. So first we have this element. Next we have this element, and instead of elements I will add indexes. So let me give it the indexes. So now let's start the algorithm. First we have this element. So our this deck is empty. So we just add the index. Then we have this element. So this element is greater, and we need greater element. We need greater element. We don't need the smaller or equal elements. Whenever we find the greater element, we check from backwards. If there is a smaller element, we will pop out the element. So just for simplicity, I will place a element with the corresponding index. So we have this 2 1. So this element is greater than this element, and we are seeing the element from backwards. So this element is great. Our current element is greater, so we just pop out the element. Now our deck is empty, so add current element. Next we have this element. This element is also greater than the already stored value, so just pop out the value and add and add the current element. So we do it just for 3 times, because our window is 3. We do it for 3 times. It's time to build the answer. For this current window, the answer is 3, and we are storing the index, so just access the corresponding element and build the answer. Our answer is 3 in this case. Next we have this window, and before that we have this element. So this element is smaller, so we will just add it. Why it is useful? So it is useful for the next window. We are just adding for the corresponding. So just add the current element. Now for this window also the maximum element is 3. So 3 is present on the left hand side, so we just view the element from the left hand side, and we will place the element here. Next let's move to the next element. Now the window will be this. Next element is 4. 4 is greater than 1, so just pop out the element from backwards. And 4 is also greater than this, so just pop out this element also. Next we have 4. Its index is 4. So for this window the maximum element is present on the front, so just print the element. Now let's move to the next window. Next we have 5. So 5 is also greater, 5 is greater than this. So add 5 with the corresponding index. So our element present on the front for this window, one for this window 145. So we have considered this. Now it's time to move to next window. So we have this window. The element is 2. Element is 2. So just push the element with the 6 index. In reality we just need to push the index, not the element. Why index? So it will make sense, just wait for it. So next we have this is the smaller element, and our maximum element for this window is present on the front. Just pick the element and add it in the answer. Next our window will be this 5, 2 and 3. So 3 is greater than this element. 3 is greater than this element. So add 3 with index 7. So for this window the maximum element is present on this side. So just add the answer. So now let me change this 6 with 2. So now it will make sense. So now we have this window, 2, 3 and 2, and this element, this corresponding element is getting out of the window, so we have to get rid of this element, the 5 element. How we will get rid of this element? So we just need 3 elements. Our current index is 8. Our window size we can take is 3. So it will give 5. So if the maximum element index is either 5 or less than 5, we will get rid of this current element. So just remove the element, and now our current element is smaller, so add the element, and maximum element is present on the front. So the maximum element is 3 for this window, so just add 3. So we have considered all the elements. So this is the answer. So let me write the steps. Our first step is to find maximum element for window K. Our next step, so we have one window, so just add the maximum element. Our third step is to find for other windows, and inside this, if front index is out of bound, so then remove that element. After this, add the current element. Before adding the current element, we need to remove the smaller elements, smaller or equal to elements, then we will add the current element. And these 3 steps we have to do for the first window also. So that's the overall algorithm. Let's code this. First find n, next the answer, next we have deck. So for the first k elements, if our deck is non-empty, then inside the deck we are adding the indexes. So access the element if the element is smaller than the current element. So current element is the maximum element till now. So get rid of the element, and we are picking the element from the last side, from the right hand side. Then we need to add the element on the last index. Not the element, the index. So after we are done for the first k elements, we need to pick the maximum element, and a maximum element is present on the first. So pick the first and it will give you the index, access the corresponding element and add it into the answer. So we have found for the first window. It's time to find the maximum element for other windows. So start from k onwards till n. If the maximum element is out of the window, means the peak element, the leftmost element is getting out of the window. So this is the window size. If this is the case, we need to get rid of the element. Next, this is same thing we have to write here. If the current element is the maximum element, get rid of the smaller elements, then add the element. So after we are done with this, we need to add for the add the maximum element for the current window also. So, and the maximum element is present on the first, on the left hand side. So then just return the answer. So this is about the algorithm. Let's give it a try. And if you guys have any doubt, feel free to ask in the comment section. And this code is given in the description box. Now let's talk about time and space complexity. So first we have this, then we have this. We just removing the smaller elements. So on the worst case, it will be order of n itself, not this while loop, but first we have for loop, then we have for loop. So first we are iterating for k, then n minus k. So the overall time complexity is order of n. Then let's talk about space complexity. For the space complexity, we need only k elements. So if the elements are more, we are removing the element. So that's about the space complexity. And if you like this video, give it a thumbs up, subscribe to this channel, and thank you all for watching.